Okay, here we go. There's the heading. So guys, a surd is basically a root. All right, so the square root of something, that root is called a surd. So we're just going to list the laws and then we're going to practice them. That's all we're doing today. Okay, that's the nth root over there. That small variable, there's an n, and that's also an n. And then that's another n there. Okay, so basically this is just saying that if you have two roots and they're the same roots, so if they're two square roots, for example, or two cube roots, or two fourth roots, whatever, as long as they're the same roots, and you're multiplying them, then you can actually combine it into one root, all right, that same root, and you can then multiply the actual values that are in the, or not necessarily values, the expressions in those roots. So if you have, for example, I'm just going to do an example in a different color here. If you have the square root of 2 multiplied by the square root of 32, now guys, also if they're wanting you to apply these laws, they also say in the question that you have to do it without the use of a calculator, all right? Because otherwise, what's the point? Because you could actually just type that into the calculator and it will give you the answer. But if we're not allowed to use a calculator for that, do we agree that 2 doesn't actually have like a whole number square root, right? The square root of 2 is actually irrational. And the square root of 32, what's that? What's the square root of 32? Okay, we don't actually know. It's going to give us some kind of decimal number. So we couldn't actually work this out without using a calculator. But now we need to notice that we can actually apply this law because we have two surds and they have the same roots. It's the square root and the square root, and we're multiplying them together. So we can put this together under one square root. And then what is 2 times 32? 64. And can we do that without the use of a calculator? What's the square root of 64 is? 8. Okay, we will do more examples later on. I just wanted you to see a simple application of this law. All right, so that's the first law. If you have the same roots, the same surds, and you're multiplying them, you can multiply the two numbers or whatever you had and put that under one surd. Then we could obviously go the other way around as well. Hey, so if you are, this isn't really a separate law, but I'll write it as one. If you had the nth root of a product, then you could break that product up into two separate ones. So it's literally law number one in reverse. All right, so if you had the nth root in your root of a product, you could break it up into the nth root of the first factor, so a times b, so the first factor would be a, multiplied by that same root of the second factor. And I'll show you now how this could be useful if you are asked to do something like the square root of 12, if you're asked to simplify that without the use of a calculator. Now, do we know what that is, the square root of 12? Again, that will be some kind of decimal value, right? But guys, can I break 12 up into a product of two numbers? And then one of those numbers might have a square root. What do you think? 4 and 3, hey, we could do that. And guys, you are going to get lots of practice in this, so don't stress if you're a bit lost at the moment. So we can rewrite 12 as 4 times 3. Now, if I'm using this law, then I could actually break this up into two separate surds, two separate square roots. Hey, I could say that this is the square root of 4 times the square root of 3. Now, can I at least calculate one of those? Hey, what's the square root of 4? 2. So now you could work this out and you could actually say that this is the same as 2 root 3. Now guys, I'm not sure if you remember in previous grades, sometimes when you typed into the calculator like the square root of 12, it would come up as 2 root 3, right? And you might have asked your teacher, where does that 2 root 3 come from? It's actually from this. All right, so if they're asking you to find the square root of a number that doesn't have a square root, or it can be a cube root as well, all right? It can actually be any surd. Then you need to write that number as the product of two numbers, one of which has a square root. So 4 times 3, for example. If I had written this as 6 times 2, would that have helped me? Okay, 6 times 2, what's the square root of 6 and what's the square root of 2? Those are two that I can't actually calculate. So you need to try and write whatever the number is as the product of two numbers, one of which actually has a square root that you can do in your head, and then you can simplify it like that. Yes? You're fine. Okay. The third one is similar to the one that we just did. And you might have actually applied this before. It's just if you have any surd of a fraction, then you can break that up into that surd of the numerator over that root or that surd of the denominator. And I think you guys have probably been applying this without actually realizing that you have been. If you have, for example, the cube root of 27 over 8. Right, it's a 1/3, 1 root, the cube root of a fraction. So you could simplify this by taking the cube root of the numerator, which we all know is what? What's the cube root of 27 is 3, hey? And then we can put that over the cube root of the denominator. So this is then 3 over 2. Okay, the fourth one is one that we don't really use all that often, but you know, I suppose it's useful to know. If you have two surds, so on the outside we have the mth root, and then on the inside we have the nth root of a, like that. All right, you could actually simplify that to just one surd. I'm sure we don't like working with two surds. All right, so you could simplify it to one surd, but the number then there will be m times n. The product of those two. Sorry, that's very small. That's an m times n there. All right, so I'll show you an example now, but you would multiply those two numbers together, and then it is just of a. So if you have, for example, they're asking for the cube root of the square root of 729. Yeah. Yes. Yeah, that's actually where this is coming from, where this law is coming from. Yeah. So guys, if you forget this law, you could do what Robin is suggesting, and you could write a, or this inner surd, you could write it in exponential form, all right, which would be a to the 1 over n, and then all of that to the 1 over n, all right, you'll get the same answer in the end. I'll do an example like that just now, but here, there's a 3 on the outside. What number is there on the inside, even though we don't write it? It's a 2, hey. So this would actually become the 2 times 3. That would be the new number on the outside of the surd of 729. So in other words, the 6th root of 729, like that. Now, I don't know if you guys know what that is, all right? But what you could do is you could kind of get away with using your calculator in this sense, All right, I'm going to show you how. You can't just go to the answer straight away because then I'm going to know that you used your calculator. But what you could do is you could use the factor button. I'll just show you quickly. And check what 729 would be equal to. So 729, remember we say 729 equals, then we do shift and the factor button, and we see that it's 3 to the power of 6, right? So if you are writing this, if you say that this is the 6th root of 3 to the 6, I will give you the benefit of the doubt, and I will say you at least knew that 3 to the 6 instead of 29. But if you're going straight to the answer, then you won't get that benefit of the doubt, if that makes sense. Now, guys, what is the 6th root of 3 to the 6? What happens to the 6th root and the exponents there? They cancel each other out, hey? So that actually will give you 3. Now, guys, the reason for why they're canceling each other out, I'm not sure if you know that. We have 3 to the 6 on the inside here, all right? And the square root of 1, or the 6th root of anything would be to the power of 1 over 6. Or the exponent on the inside becomes the numerator and the number on the outside becomes the denominator, right? And what is 6 over 6? Just 1. Okay, so that's why they actually cancel each other out. But you can just remember that if you have the same number there and in the exponent, they will cancel each other out. Right, it's like taking the square root of 2 squared. I'm sure we all know that that is 2, hey? Because the square root and that exponent of 2 will cancel each other out. Okay, now guys, another way, if you didn't remember this law, you could do what Robin was suggesting. So you could, if you were given this, the cube root of the square root of 729, you could solve this, or you could find this just by using exponents. All right, so if we wrote these two as, or in exponent form. So let's do the inner surd first, the inner root. The square root of 729, how will I write that in exponent form? What is the exponent of 729 on the inside? 1, and the number on the outside is 2. So this will be 729 to the power of a half, right? If I'm just writing that inner surd, that square root of 729 in exponent form, it's 729 to the power of a half. Now, if I want to write this whole thing, which is to the power of, or which is in the cube root there, right? How would I do that? I think I'll just leave my inner thing as 729 to the power of a half. And the cube root is to the power of 1 over 3. Right, so that's the square root and that is the cube root. Does that make sense? All right, so the square root is to the power of a half and the cube root is to the power of 1 over 3. And now what do I do if I have an exponent inside a bracket and outside a bracket? I times them together, hey? So I'm going to get 729 to the power of a half times a third. Now a half times a third, I'll do it on the side here. We multiply the numerators together. 1 times 1 is 1, and 2 times 3 is 6. Right, so that is going to become 729 to the power of 1 over 6. And now this is where this also becomes helpful. Hey, do we see that we're actually going to end up with the same thing? Because now 729, we know because we used our calculators. It would be nice if you knew that off by heart, but it's quite a big number, so I'm not sure if you do know that. 3 to the 6 to the power of 1 over 6. And now again, we have an exponent inside a bracket and outside a bracket. So we would multiply those together. So we would have 6 times 1 over 6. Do you see that those 6s are going to cancel out? Right, so this will then again give you 3 to the power of 1, which is just 3. So guys, I don't want you to feel overwhelmed by all the numbers. All right, I get a sense of that by looking at your faces. But you must just go step by step. If you remember this law, great. It makes it quite easy for you. Okay, if you don't remember this law, you can do it in a different way by writing your surds in exponential form. And just go step by step, guys. All right, just like I did. Try to not leave out steps. And then, yeah. I know also 729 is a big number, so you might not know what that is, but you can kind of cheat by using your calculator for that one. All right, that was the fourth law. There is just one more, which we have done already, but I just want to write it down again. And that is, let's do it on the side here. That is just a reminder of going from surd form to exponential form. Because it can be useful. We saw now in this last example that it gave us a second method. If you have the nth root of a to the m, you can change that into exponential form by taking that same base. The exponent inside the surd becomes the numerator of your new exponent, and the number outside the surd becomes the denominator of the new exponent. Right, so that's just a reminder of that, but we did use it now in this example. Okay, we're ready for some examples. Are there any questions at this point, guys? Okay, let's do some examples and then maybe you will feel a bit better about this. Not that last one. You can write examples so long, guys. And then number one, sorted. Okay, write the square root of 50 in its simplest surd form. And guys, let's just assume for all of these, you're doing them without the use of a calculator. I'm not going to write that down every time. Okay, the square root of 50. Do we know what that is off by heart? No. All right, so we're going to have to use that second law where we're going to rewrite 50. I'm just going to write it there so that I know that that's what I'm working on, the square root of 50. Can I write 50 as the product of two numbers, one which has a square root, one of which, sorry, has a square root? 25 and 2, hey? So we're going to say the square root of 25 times 2. Now, if we're looking at that second law, where if you have one surd and you have a product in the surd, you can break it up into two separate ones and the product of those. So we're going to say that that is the square root of 25 times the square root of 2. And what is the square root of 25? 5. And then we just write the root 2 next to it. All right, because when we multiply two things together, we can just write them next to each other. Yes. So this is a step that I will have to see. This is almost your proof that you're not using your calculator, but this step you don't have to show. Right, so guys, it's fine if you go straight from your square root of 25 times 2 to your answer, but you have to show the 25 times 2. All right, that is proof that you're not using your calculator. Now, guys, if they're giving you a number that's a bit difficult, you're not quite sure, you can again use your little cheat here. All right, so if you're using the calculator, which I know you're not supposed to do, but yeah, we'll blow over that for now. So the square root of 50, I think all of you would have known 25 times 2. Okay, this is quite an easy one, but they won't always be easy. You can again use your factor button. So you can use 50 equals and then shift and factor, and it will give you 2 times 5 squared, all right? Which you can write. You can say it's the square root of 2 times 5 squared, because we all know that 25 is 5 squared, right? Is that fine with everyone? So it's fine if you write it like this. You'll get that mark still. Now, if you split that up, you'll get the square root of 2 multiplied by the square root of 5 squared. And on the previous page, we discussed that a square root and a square will cancel each other out. All right, so this will give you square root 2, and that will be 5. So your answer again is 5 root 2. Okay, so if the number is a bit difficult, like we had 729 in the previous one, you can use that as a bit of help. And guys, just please make sure that your final answer is written like this, that it's the whole number and then the surd next to it. Okay, please don't write root 2 and then the 5. It's almost like you're doing like a 5x. All right. Okay, that's the first one. It's just a very simple one. They can ask us to simplify a whole bunch of terms together though. So they can say simplify, and then I'll just do a colon and then I'll write all of them next to each other. So the square root of 98 minus the square root of 32 minus the square root of 18. Okay, so now they've given us square roots of 3 numbers that actually don't have square roots. All right, so in order to simplify this, we're going to have to break all 3 of those numbers up into its factors. Okay, so 98, not sure, can you guys think of 2 numbers that you can write that as? 98, what's 98 divided by 2? 49, hey, does 49 have a square root? Yes, okay, good. So we can try 49 times 2. And guys, that's also a nice way of doing it. Just take the number divided by 2, see if the answer does actually have a square root, right? That's what I always start with. Okay, let's look at the next one. The square root of 32 doesn't have a square root, but what's 32 divided by 2? 16, so that one will work. And then 18, what's 18 divided by 2? 9, and 9 has a square root. But if you are unable to do that, you can use the calculator. All right, so the calculator will give you 7 squared times 2 for the first one, and 4 squared times 2 for the next one, and then 3 squared times 2 for the last one. Okay. Now, guys, can we skip this middle step now for this one? This first term we would break up into the square root of 49 times the square root of 2. What's the square root of 49? 7. So this is going to be 7 root 2. Right, is that fine? So you take the square root of the one that actually has a square root, and then just root 2. Minus, what's the square root of 16? 4. So 4 root 2. And then minus, what is the square root of 9? 3. Now, guys, what we have here now is that we have like surds. That's what we call them. All right. Do we see that in all 3 of these terms? We have the same surd kind of attached to the number, the whole number. So we're going to approach this as if it was 7x minus 4x minus 3x. All right. But just in the place of x, we now actually have a root 2. So what is 7 minus 4? 3, and then minus 3 is 0. So this would technically be 0 root 2. But we all know that that is actually just 0. Okay, you don't have to write that 0 root 2 there. Just write it in for this one because it's the first example. Okay, so these, let's maybe just make a little note on the side there to say that these are actually like surds. And guys, if they weren't like surds, so if you had a square root and a cube root, for example, you couldn't add or subtract those. Or if you had the square root of 2 and the square root of 3, those also wouldn't be like surds. All right, so you also couldn't add or subtract them. So it has to have the same root and the same number in that root. Okay, let me just see if there is an example where you don't have like surds. Not. Okay, but it might come up in the homework that I'm going to give you. Okay, so if there's like a root 2 and a root 3, you can't add or subtract those. Just keep that in mind. Okay, number 3. I want you guys to try this one on your own quickly. I'm going to give you a couple minutes. We have root 12 plus root 48 minus root 75. I want you guys to do that one on your own, please. Yep. Sure. Okay, let's take a look. Right, there we go. So I wrote 12 as 4 times 3. 48 was 16 times 3, and then 75 was 25 times 3. But guys, if you use your calculator, it's fine if you wrote these as squares. All right, but they were all times 3 in this case. So the square root of 4 is 2, the square root of 16 is 4, and the square root of 25 is 5. Now do we see that we have all like surds again? They are all square roots and they're all the square root of 3. So you say 2 plus 4 is 6, minus 5 is 1 root 3. For where now? 4 times 12. Well, 12 you can then again break up into 4 times 3. See, so if you said 4 times 12, you would be left with 2 root 12. But then root 12, so 2 root 12 can be simplified even further. See. So guys, if that happens, it's fine. So if you said something different here, so if you said 4 times 12, for example, for 48, I can just do that on the side here. If you have 4 times 12, then that would give you 2 root 12. But then you would obviously notice that it's not a like surd. Now, it doesn't always have to be a like surd, but that could just maybe be a hint that you need to check whether you've actually simplified it fully. Because 12, we can now again write as 4 times 3. Okay, so then you would have to go another step and you would then have to say 4 times 3. In which case you now have 2 times the square root of 4, which is another 2. So that would give you 4 root 3. Okay, you can copy down the next one so long. We'll do that one now. So we're simplifying 6 plus root 18 over 3. So guys, very important. In the numerator, how many terms do I have? 2. So am I allowed to cancel out if I have more than one term anyway? No. All right, very important. I'm going to write that on the side here. 2 terms, therefore, cannot cancel. You can only cancel out if you have one term over one term. Now, how can I turn 2 terms into one term? By factorizing, okay? But at the moment, guys, if we look at those 2 terms, do I actually have a common factor there that I can possibly take out? Not in the way that it's written now. Hey, the square root of 18, I'm going to have to simplify that first. So let's do that. We have 6 plus, now 18. Product of which 2 numbers will give me 18? 9 and 2. So I can write that as 6 plus the square root of 9 times 2. And remember, guys, you have to show that mark to prove to me that you're not using your calculator. And that is then all over 3. which I can now simplify further because 6 plus the square root of 9 is 3. Do I now have a common factor? Yes. Now I have a common factor of 3 in those two terms. Do we see that? 3 goes into 6 and into 3 root 2. So we can now take out 3 as a common factor. What is 6 divided by 3? 2 plus 3 root 2 divided by 3 is just root 2, hey? So that is what's left when I divide both of those terms by the common factor, which is 3, and that was all over 3. How many terms do I now have at the top? 1. Okay, because I have a number and a bracket, that's 1 term. So now you are allowed to cancel out. So let's add that 1 term. Yeah, you would have to. That is the factorizing step. Yeah, so you would have to show that. What you could also do, because you just have 1 term in the denominator, you could split the fraction up, but you would then have to show that. Yes, Talia? I'm taking out 3 as a common factor. So 6 divided by 3 is 2. And 3 root 2 divided by 3 is root 2. Okay, so now we can cancel out. Is there something that's the same at the top and the bottom that we can cancel out? The 3's, hey? So what am I left with? 2 plus root 2. Are those two like terms? No, so I can't add them together. Right. If it was a root 2 plus root 2, then I could add them. But it's just a 2 plus root 2, so they aren't actually like terms. Okay, I just want to do one more example quickly where we are multiplying out so that you can see what would happen in that case. Are there any questions so far, guys? Right. Just find, okay, there's another page. Which number is this now? This is number 5. Okay, 3 root 3 minus root 8, and that is all squared, that bracket. So guys, remember a bracket squared is not just the first term squared and the last term squared. We discussed that the other day. You get 0 if you do that straight away. All right, that is a breakdown. You have to, there is a shortcut that you can use, or you have to rewrite this as 3 root 3 minus root 8 multiplied by itself. Remember, that's what it means when you square something. You're multiplying that thing by itself. Yes, I'm going to do that later. Well, then you would have a number in front and a surd, so maybe, but it's fine. You would get to the same answer as long as you don't make a mistake. All right, do we see that we have 2 terms and 2 terms? So these are 2 binomials. And what do I do when I multiply 2 binomials? I FOIL. We're going to have to do firsts. So we're going to have to do 3 root 3 multiplied by 3 root 3. Now, guys, what would you have done if it was 3x times 3x? You would say 3 times 3 is 9, and x times x is x squared. We do the same thing here. 3 times 3 is 9, and root 3 times root 3 is root 3 squared. Okay, so I'm going to put that in a bracket just so that the root and the square don't get mixed up. And what is that actually going to be, guys? What's root 3 squared? What happens with the square root and the square? They cancel each other out. So that's actually just going to be 3. Okay, but because this is the first example that we're doing, I just want us all to write that down so that you don't get confused later on. All right, now we need to do O is outer. So 3 root 3 times negative root 8. What's a positive times a negative? Negative 3 times, there's a 1 there in front there. That would give you 3. And now we have the square root of 3 multiplied by the square root of 8. Now, what was that first law? If you have the product of two surds, they have the same roots, and you're timesing them together, you can put that together as 1 surd with 3 times 8. Okay, we'll do that just now. Again, just because this is the first example, I want us to write down every single step so that if you look back at this, you're not confused about where we got the answers from. If we now do the inners, do we see we're going to get the same thing? Negative 3 root 3 times root 8. I'm just going to write that again. You could obviously put those in brackets if you wanted to, right? Just in case you're worried that you'll get confused there. And now we need to do the lasts. So a negative times a negative is a positive, and root 8 times root 8 is root 8 squared. Okay, let's simplify what we can there so long. So we have 9, and then we've already discussed this. The square root and the square will cancel each other out. So that will just become 3. If you want, you can just write, you can go straight to 27. Okay, again, I'm just writing down every step. Here we have negative 3, and then in 1 square root, what is 3 times 8, guys? 24, hey? So do you see I'm combining that? I'm doing the product in 1 third. Okay, that was the first law that we wrote down. We get the same thing in the last or the third term. You have 2 of the same surds that you're multiplying together, so you can combine it in 1 surd and multiply those numbers. And 3 times 8 again is 24. Rule number 1. The same surd that you're timing, you can put it in 1 surd. Okay, and then for the last one, we have plus. What happens with this square root and that square? They're canceling each other out, so that is just 8. Okay, 9 times 3 is 27. Now guys, before because we're going to have to change this 24, obviously, we're going to have to write it as a product of 2 numbers, but do we see that we have like surds? Is it fine with you guys if I put it as 1 term? So negative 3 or negative 3 minus 3 is negative 6. Okay, so I'm just simplifying those middle terms, and then we have a plus 8. What is 27 plus 8? 35, hey? Now let's sort out this 24. I need to write 24 as a product of 2 numbers, one of which has a square root. Yes. Let's check. What's 24 divided by 2? 12. Does 12 have a square root? No, so that's not going to work. What about 24 divided by 3? What? 8. Does 8 have a square root? No, so 3 also isn't going to work. 3 and 8. So the next one would be 4 and 6. All right, 4 has a square root at least, so that will be 4 times 6. And we've already added that 8 there. So now we can finally start getting to our answer. What is the square root of 4? 2. So this whole thing, right, this surd is 2 root 6. But guys, we already have a 6 there in front of that root. So what am I going to have to do with that 6 and that 2? I'm going to have to multiply them together, hey? Otherwise, I must write 6 times 2 in front. So that will be minus 12 root 6. Okay, so see what I'm doing? The square root of 4 times 6 there, the square root of 4 is 2. So I'll all fine with this. But I already had a 6 there in front. Okay, so this is technically 6 times this whole thing. And that's where that 12 is coming from. Okay, because the 6 and 2 you would have to multiply together. All right, guys, so that's a lot of steps. Yes.
Sorry. It was square root in 4. And the 6 doesn't have a square.
Is that? Yes. So for this one, you would get your marks either if you decided to write this line out, you would get 2 marks for that line, right? But you could technically skip this line. So you could have just written 9 times 3 instead of 9 times this whole thing. And you could have done the 3 times 8 immediately to get your 24 and your 24. And you could have done this straight away. All right. So it was 2 marks for either one of those 2 lines, just showing the actual multiplying out. Then you would get a mark for doing the splitting up thing, the 4 times 6. And you would get a mark for putting them together as 6 as well. And then you'll get a mark for your final answer. So 5 marks. So guys, you could skip some of these steps, all right? I've shown every single step in detail so that you're exactly sure where everything comes from. But as long as I can tell from your working that we didn't do the calculator, then that would be fine. Okay, let's see, what are you doing for homework? Exactly. Yes, exactly. Okay, you are doing you're standing up against maths. Okay, well then we don't want to do homework, unfortunately. Okay, no, I'm taking that away. I'm giving you 7. Sorry guys, I changed my mind, so it should be 6 and 7, but yeah, sorry, because I don't want to give you 8. So 6 and 7 there. Guys, you have 8 minutes, you can finish it in that time. You have nothing to complain about.